Hey everyone, this is Dr. Walker. Let's do an example from v502 on the scalar product. In this example, we are given two vectors a and b, and we want to find the scalar product of the two vectors and also the angle between the two vectors. So in video 502, we talked about how to find the scalar product of two vectors, and we said that we're just going to add all of the x and the y components separately. So we said that a dot b is going to equal ax times bx plus ay times by, and if we had z components, then we would add az plus bz, but in this case, we're only in two dimensions. So we're going to have 2 right here for ax, this is ax, this is ay, this is bx, and this is by. So bx is the -1 here. And then we're going to add 3 for the ay times 2 for the by. And that's going to give us 4. So the scalar product is going to be 4. What is the angle between these two vectors? If we were to roughly sketch them on a graph here, we would get, let's see, 2 and then 3. This is just a very rough sketch for vector A is going this way, and then vector B is negative, and then 2 vector B is going this way. So what is the angle theta between the two vectors is what we're looking for. And we said that to find the angle between vectors, we know that cosine of theta is equal to the dot product over the product of the magnitude of each vector. So we already have the dot product. Let me make sure these looks like vector signs here. Now we need to find the magnitude of each vector. We can do that on the side. We know that we have to use the Pythagorean theorem. The magnitude of A is the square root of ax squared plus ay squared to the square root of 2 squared plus ay squared, which is 3 squared. That gives us square root of 13. And then the magnitude of b is the square root of bx, which is -1 squared, plus by, which is 2 squared. And that gives us the square root of 5. And now we are ready to find cosine of theta is going to be the dot product, which is 4 divided by square root of 13 times square root of 5. And that is going to give us 4 over the square root of 65. And haven't rounded yet. That's why I'm leaving the square root here. And then to find theta, we're going to take inverse cosine of 4 over square root of 65. And that will give us an angle of about 60.3 degrees. So the scalar product is going to be a scalar. You can think of it as the projection of one of the vectors onto the other multiplied by the magnitude of that other vector, right? You can think of it, I didn't say this earlier, so I just wanted to show this really quickly. If you have vectors a and b, right, you can think of it as here, this b parallel, right, the projection of b onto a times a, that's b cosine theta times a. Or if you have those same two vectors, you can think of it as the projection of vector a onto vector b, right? The part of vector a that goes along the b direction. So the a parallel, which would be a cosine theta times b. That was just a little aside for the dot product. And you can also use a dot product to find the angle between two vectors.